We have an arithmetic progression, and in this arithmetic progression it's given that the pth term is a and the qth term is b. Then using this we need to prove that the p plus qth term, the sum up to the p plus qth term, that value is given by this particular expression. So let's begin. First we'll have to specify the first term and the common difference. So let the first term, we're going to represent the first term by the letter A in uppercase. That's because we already have the letter A in lowercase used up. And the common difference, we'll consider the common difference B, also represented by the letter D but in uppercase. Fine. Now we know that the nth term of an arithmetic progression is given by a plus n minus 1 times the common difference d. Then this would mean that the pth term will be equals to a plus p minus 1 times the common difference d. So here it's given that the pth term is a, so we have a equals to a plus p minus 1 times the common difference d. So let's label this as equation number 1. And we have the qth term, which is given by a plus q minus 1 times the common difference d. So here it's given that the qth term is b, so where b equals to a plus q minus 1 times the common difference d. So let this be equation number 2. Now what we'll do, we will subtract 2 from equation number 1. So on the left hand side we have a minus b, that will be equals to, on the right hand side we have p minus q times d. Solving for d, we get d equals to a minus b divided by p minus q. So we have obtained the common difference. So let's label this as equation number 3. Now we can also obtain the first term. We can use either equation 1 or 2. So let's use equation number 2. Equation number 2, so a value will be simply equals to b minus of q minus 1 times d, and d can be replaced with a minus b divided by p minus q, which will be equals to, so we have a common denominator of p minus q, and in the numerator we have b multiplied to p minus q, where bp minus bq. Then in the numerator we're going to multiply q minus 1 with a minus b, so we have qa plus qb. Then we have positive a minus b. Now clearly few of the terms will get cancelled out, so we have negative bq and positive qb cancelling out, and we are now left with bp minus aq plus a minus b whole divided by p minus q. So this is our first term. So let's label this as equation number 4. Now what we'll do, we'll use 3 and 4 to find out the sum up to the p plus qth term. So therefore the sum up to the p plus qth term, this will be equals to, so we'll use the general formula. The general formula is the sum up to the nth term, this is given by n over 2 whole multiplied to 2 times the first term plus n minus 1 times the common difference d. So therefore we have p plus q, since our nth term is actually p plus qth term, so we have p plus q over 2 whole multiplied to 2 times a. The a here will be bp minus aq plus a minus b whole divided by p minus q, plus we have p plus q minus 1 times the common difference d, which is a minus b divided by p minus q. So we'll simplify this. We'll get p plus q divided by 2 whole multiplied to, so we'll combine the two terms within the parentheses. Our common denominator will be p plus q. In the numerator we have 2 times bp minus 2 times aq plus 2 times a minus 2 times b, plus we're going to multiply a p plus q minus 1 with a minus b. So we have p times a minus p times b plus q times a minus q times b. Then we have negative a plus b. Fine. Now we have p plus q over 2 whole multiplied to, so we have in the denominator p minus q. Now in the numerator let's combine few of the terms. So we have 2bp and negative bp, so this will become positive bp. Then we have plus aq and minus aq, so this is going to become negative aq. Then we have 2a minus a, so this is going to be positive a. Then we have negative 2b plus b, so this is going to be negative b. Fine. And now we are left with plus pa and minus qb. Fine. So we will further simplify this. Now we will have p plus q over 2. So we'll combine the first term and the last term. So here we'll take b as the common factor. So we'll have b times p minus q. Then we'll consider negative aq and positive ap. So here if we take a as the common factor, let's take positive a as the common factor. So we'll have p minus q plus a minus b all divided by p minus q. Fine. So this will give us p plus q divided by 2. Now if we consider this as the first term, this is the second term. So from the first term and second term, we can take p minus q as the common factor. So this will get multiplied to a plus b plus a minus b. Now what we'll do, we'll divide both of them by p minus q. And we'll also divide a minus b with p minus q. So immediately we see that p minus q and p minus q cancels out. And this gives us the final value, p plus q over 2 all multiplied to a plus b plus a minus b divided by p minus q. So this is the sum to the p plus qth term, hence proved.